Okay, now today we discuss about the armature reaction in alternator. So what happens when armature reaction occurs in an alternator? Okay, so content of today's lecture. So we will discuss the definition of armature reaction, what is the armature reaction, then the various effect of armature reaction for different type of load or power factor, that is for unity power factor load, zero leading power factor load, zero lagging power factor load, intermediate power factor load, and finally we'll summarize the today's topic, and also in the last we will see the animation regarding the armature reaction. Okay, so this is the basic image construction image of alternator. Okay, in which we have a armature winding, then rotor winding, that is rotor with the field winding. Okay, so what happens, we already discussed the construction of the alternator. So when DC supply, here is the DC supply. Okay, so this DC supply is given to the field winding. This field winding is wound on the magnetic pole. Okay, so this is the rotor construction. Okay, so on rotor side we have a magnetic pole, and on this magnetic pole we have a winding. This winding is known as the field winding. Okay, and DC supply is given to this field winding through this slip ring and brushes. Okay, so whenever the DC supply is given to the field winding, what happens, current will flow through this field winding. Okay, so as soon as the current is flowing through this field winding, what happens, the magnet is magnetized. Okay, so as soon as this magnet is magnetized, what happens, the magnetic field, or we can say that the magnetic flux is produced. Okay, so whatever flux produced by this magnetic pole, that is known as the main field flux. Okay, and it is represented by phi m. Okay, so the flux or field produced by the magnetic pole when DC supply is given to the field winding is known as the main field flux, and it is denoted by the phi m. Okay, and we will take this main field flux phi m as the reference for the phasor diagram. Okay, now we assume that the load is connected to the alternator. Okay, so when the load is connected to the alternator, at that time what happens, the current is flowing through the armature winding. Okay, because what happens, this rotor is in the rotating condition, so this rotor rotates with the help of the prime mover. Okay, so this magnetic field is in the rotating condition, or we can say that it is a dynamically flux, or we can say it is a rotating magnetic flux, and this magnetic flux, rotating magnetic flux, is cut by the armature winding. So according to Faraday's laws of electromagnetic induction, EMF is induced in armature winding. Okay, up to this point there is an EMF induced in the armature winding. Okay, and load is not connected, that means on armature side the output circuit is in the open condition. Okay, now we are connecting a load to the armature winding. Okay, or we can say that the load is connected to the alternator. Okay, so as soon as the load is connected to alternator, what happens, current is flowing through the armature winding. Okay, so this is the armature winding and current is flowing through the armature winding. Now in electrical there is one rule. Okay, when current is flowing through any conductor, when current is flowing through any conductor, at that time magnetic field or magnetic flux is produced around it. Okay, this is the basic law in electrical engineering. When a current is flowing through any conducting material or conductor, at that time the magnetic flux or magnetic field is produced around it. Okay, so what happens here, this is the armature winding. Okay, so there are more than one conductors in the armature winding, and in each and every conductor current is flowing. Okay, so around all these are armature conductor, the magnetic flux or magnetic field is produced. Okay, so whatever magnetic flux or magnetic field produced by the armature winding, that is known as the armature flux or armature field, and it is denoted by phi A. A stands for armature. Okay, so when load is connected to alternator, we there are two magnetic flux produced in the alternator. First is the magnetic flux produced by the magnetic pole, that is the main field flux phi m, and second magnetic flux or magnetic field is produced by the armature winding, that is denoted by phi a. Okay, so when alternator operates on load, at that time these are the two magnetic flux or magnetic field produced in this alternator. Okay, now what is the armature reaction? Okay, so when two magnetic flux or magnetic field are there in the same alternator, so what happens, the effect occurs on the main field flux, or we can say that this armature flux or armature field will affect the main field flux. Okay, so whatever effect is there on main field flux by the armature flux, that is known as the armature reaction. So reaction is there on main field flux of the armature flux, that's why it is known as the armature reaction. Okay, so in this armature we have armature flux, this is the main field flux, and the effect of armature flux on main field flux is known as the armature reaction. Understood the definition of armature reaction? The effect of armature flux on main field flux is known as the armature reaction in alternator. Okay, and due to this, the main field flux will distort. Okay, due to the effect of armature flux, the main field flux will distort, or we can say that the main field flux either strengthen or it will weaken. Now the effect of armature reaction. Okay, so we have a different type of load. We have a resistive load, we have an inductive load, as well as the capacitive load. Okay, and each and every load has different power factor. So for pure resistive load, the power factor is the unity power factor. For pure inductive load, the power factor is the zero lagging power factor, and for pure capacitive load, the power factor is the zero leading power factor. Okay, so for different types of load, the power factor is different. So whenever the different types of load is connected to the alternator, at that time the armature reaction effect is also different. So when, what is the effect when resistive load is connected to alternator, what is the effect of armature reaction when inductive load is connected, and what is the effect of armature reaction when capacitive load is connected to alternator. So we are going to discuss this effect of armature reaction when load is resistive or inductive or capacitive. Okay, so first of all, the armature reaction of unity power factor. So we assume that the load connected to alternator is of unity power factor, that means the pure resistive load. Okay, so pure resistive load is connected to alternator. So we are going to discuss the effect of armature reaction for unity power factor load. Okay, so so when resistive load is connected to alternator, at that time what happens? The load current will start to flow through the armature conductance as usual, the working principle. As the load is resistive, the armature current will be in phase with the induced voltage. Okay, here, okay, here we are taking main field flux phi F or phi M. Okay, it is also denoted by phi f or phi m. Okay, so we are taking this main field flux phi m as a reference for the phasor diagram. Okay, so this red arrow indicates the main field flux phi m. Okay, now what happens when resistive load is connected? At that time the current is flowing through the armature. Okay, Okay, and EMF is also induced in the armature winding. Okay, so this armature winding or the EMF induced in the armature winding and the current flowing through the armature both are in phase. Okay, and both are legs behind the main field flux by 90 degree. Okay, so here is the EMF induced in the armature, here is the armature current, and both are in phase with each other, and it lags behind the main field flux by 90 degree. Now what happens, as the load current or armature current is flowing through the armature winding, what happens, armature flux is produced, and this armature flux is also in phase with the armature current. Okay, so whatever flux, armature flux produced by the armature current or armature winding, that is also in phase with the armature winding or armature current. Okay, so we can say that this armature flux lags behind the main field flux by 90 degree. Okay, so the phasor angle is the 90 degree in between the main field flux and the armature flux. Okay, so as you can see the waveform, that the armature flux will cross and distorts the main flux at one point, thereby weakening the main flux. This is said to be cross magnetizing effect. Okay, so here what happens in this portion, in this portion the main field flux and armature flux will help each other, but after this point what happens, the armature flux and main field flux are in opposite direction. Okay, so it will weaken the main field flux. Likewise in the s pole magnet, what happens, up to this point, in this what happens, both are in phase with each other. Okay, but after this point both are opposite in this direction. So in this condition it will help the each other, but in this condition it will oppose the each other. Okay, so the resultant flux, that will distorted type, and it will weaken the main field flux. Okay, so the effect is known as the cross magnetizing effect. So when power factor is the unity or the pure resistive load is there, at that time the effect of armature reaction is of cross magnetizing. So in which what happens, the main field flux will reduce as well as it will be distorted type. Okay, so this effect is known as the cross magnetizing effect, in which the main field flux and armature flux are 90 degree apart. That means we can say that the armature flux lags behind the main field flux by 90 degree. Okay, so that will we can see in this the waveform of armature flux and the main field flux. You can also notice the armature flux assists the main field flux at another point. Okay, so what happens, as I already discussed, that in this portion it will assist, in this portion it will oppose, in this portion it will assist, in this portion it will oppose. Okay, so the portion in which the main field flux and armature flux assist each other, in this condition the resultant flux or the main flux will increase, but in this portion it will oppose. That means the main field flux reduces. Okay, so the effect is known as the cross magnetizing effect, in which the flux is main field flux is distorted as well as the magnetic flux will reduce. Okay, so without causing much change to the generated EMF, the main field flux will get distorted. So in this cross magnetizing effect, the main field flux will get distorted type, and the generated EMF will not change so much. Okay, so this effect is known as the cross magnetizing effect. Okay, so in another words, we can say that flux at the trailing pole tip is increased. Leading pole tips means what happens if we see this figure. Okay, so here we assume that the reference point. Okay, so here the reference point, so the pole which comes first to the reference point, that is known as the leading pole tips, and the pole tips which comes later is known as the trailing pole tips. Okay, so in this effect what happens on trailing pole tips, the flux is increased, while at the leading pole tips the flux reduces. So due to this, the armature reaction for resistive load is said to have a distorting effect, maintaining the constant average field strength. Okay, so this is the effect of armature reaction. The effect is the distorting effect. Okay, now next we discuss the armature reaction for lagging power factor. Okay, so when an inductive load, so obviously we knew that inductive load has a lagging power factor. Okay, so when an inductive load with zero lagging power factor is connected to alternator, the load current starts to flow through the armature conductor as usual. Here what happens, the load current will be delayed by 90 degree, and so the armature flux produced will also be shifted by the 90 degree with respect to the poles. Okay, so look at this. Okay, this is the main field flux phasor, and this is the armature flux phasor, and this is the induced EMF. Okay, so here what happens, this load current will comes in direct opposition of the main field flux. That means the angle between this main field flux and armature current or load current, that is the 180 degree. 90 degree delay, that means in when unity power factor is there, at that time here is the load current is here. Okay, now it is delayed by the 90 degree, so the angle between main field flux and load current or armature current, that becomes 180 degree. Okay, okay, so the load current will be delayed by 90 degree, and the armature flux produced will also be shifted by the 90 degree with respect to the poles. So there will be a phase difference of 90 degree between armature flux and the main field flux. It can be seen that the armature flux will be in direct opposition to the main field flux. Okay, in this phasor diagram we can easily see that the armature flux and main field flux both are in direct opposition. Okay, so what happens in this waveform also. Okay, this red waveform is for main field flux, this green dotted waveform is for armature flux. Okay, so in end phase here, if we take this the reference point, so what happens, here is the maximum main field flux, and in direct opposition here we have a maximum armature flux. Okay, so when the armature flux is in direct opposition, that means the main field flux gets decreased. We can due to the direct opposition of the armature reaction. Okay, so this effect of armature reaction is said to be demagnetizing effect. Okay, in unity power factor, what is the effect of armature reaction? That is the cross magnetizing effect. That means the value is not reduced so much, but it will distort the main field flux. Okay, whereas in this lagging power factor load, the effect of armature reaction is demagnetizing effect. That means the armature flux is in direct opposition to the main field flux. Okay, so what happens, the magnitude of main field flux is reduced, and as the magnitude of main field flux reduced, that means the induced EMF will also be reduced. Okay, and induced EMF reduced, that means the effect is known as the demagnetizing effect. Why we can say that a demagnetizing? Because the magnetization reduces, and magnetization reduces, that means we can say that it is a demagnetizing effect. Okay, so due to this the main field flux gets weakened, and so the EMF induced will be reduced. Now as the induced EMF will be reduced, that means we have to keep the induced EMF constant. So to maintain the constant generated EMF for induced EMF, what we have to do, we have to increase the excitation, field excitation, to overcome the demagnetizing effect. So when the load is lagging type, power factor is lagging load type, at that time what happens, the effect is the demagnetizing effects, and due to it the induced EMF reduces, and we have to maintain the induced EMF at constant value. What we have to do, we have to increase the field excitation, and by adjusting the field excitation we can overcome the demagnetizing effect of armature reaction. Okay, now next is the leading power factor armature reaction, effect of armature reaction for zero power factor leading load. Okay, same here, when a capacitive load with zero leading power factor is connected, the load current starts to flow through the armature conductors. In this condition the load current will be advanced by 90 degree. In lagging load what happens, it will be delayed by 90 degree, but in leading power factor load what happens, the load current will be advanced by 90 degree, and so the flux produced will also be advanced by 90 degree with respect to the induced EMF. Okay, look at this way. Okay, so what happens here, this red phasor is the main field flux. Okay, now what happens, the armature flux produced by the armature winding, that is advanced by the 90 degree from this generated EMF. Okay, so now what happens, the armature flux and main field flux becomes in phase with each other. In phase, that means the phasor angle between armature flux and main field flux is zero. Okay, both are in phase, that means the phasor angle is zero. Okay, so what happens, both armature flux and main field flux becomes zero at the same time, becomes maximum at the same time. Okay, so at this position the both magnetic flux, main field flux and armature flux are zero. At this point what happens, both main field flux and armature flux are maximum. Once again at this point it becomes zero, at this point once again becomes maximum. So at same time the main field flux and armature flux will become zero and maximum. Okay, so we can say that the armature flux and main field flux are in phase with each other. Okay, so we can say that both are in phase means the armature flux helps the main field flux, it assists the main field flux. Okay, so it helps or assists the main field flux, that means what we can say, the main field flux increases. Okay, so main field flux increases, that means more flux is cut by the armature conductor, so more EMF is generated. Okay, and what happens, the main field flux increases, that means which type of effect occurs, this effect is known as the magnetizing effect. That means we can say when the leading power factor load is connected, at that time armature flux and main field flux are in phase with each other, so armature flux assists the main field flux, so finally the main field flux increases, and main field flux increases, that means the effect is known as the magnetizing effect. Okay, now main field flux increases, that means more flux cut by the conductor, so more EMF is generated. Okay, and if we want to keep the generated EMF at constant value, what we have to do, we have to reduce the generated EMF. Now how can we reduce the generated EMF? So if we want to reduce the generated EMF, we have to reduce the main field flux. Now how can we reduce the main field flux? This main field flux depends on the excitation. Okay, so what we have to do, we have to reduce the excitation of the field winding. Okay, so as soon as the field winding excitation is reduced, the main field flux also reduced, and it will keep the generated EMF at constant value. So we can adjust the generated EMF at constant value. Okay, so by reducing the excitation, field excitation, we can overcome the magnetizing effect of armature reaction. Okay, so in unity power factor, the effect is the cross magnetizing, that is the distorting effect. For a lagging power factor load, the effect is the armature reaction effect is demagnetizing effect. Whereas for leading power factor load, the effect of armature reaction is of magnetizing type. Okay, and for intermediate power factor, okay, that means it is in between leading to unity or unity to lagging, or in between lagging and leading, that is known as the intermediate power factor. Okay, so in this intermediate power factor, the effect of armature reaction is partly distorting and partly demagnetizing. Okay, so when it is nearer to the leading power factor, the effect will be partly distorting and partly magnetizing. When it is nearer to lagging power factor type, that means the effect is partly distorting and partly demagnetizing. So this is the armature reaction for intermediate power factor. Okay, so from this explanation we can summarize that when an alternator supplies a load at unity power factor, the effect of armature reaction is partly cross magnetizing and partly distorting type. The effect of armature reaction is demagnetizing when an alternator supplies a load at lagging power factor. When an alternator supplies a load at leading power factor, the effect of armature reaction is magnetizing effect. And when alternator supplies a load of intermediate power factor, the effect is partly distorting and partly demagnetizing. That means nearer to leading it is partly distorting and magnetizing, nearer to lagging it is partly distorting and magnetizing. The effects of armature reaction may cause the generated EMF to vary. So it will affect the generated EMF. For demagnetizing effect, the generated EMF will reduce. For magnetizing effect, the generated EMF will increase. So in order to overcome, the main field flux is varied to generate the rated voltage. That means we have to adjust the excitation of the field. So how can we overcome the effect of armature reaction? So to overcome the effect of armature reaction, we have to adjust the field excitation of alternator. Okay, so by adjusting the field excitation, we can adjust the main field flux, and according to that we can adjust the generated EMF to the constant value. Okay, now we will see the animation regarding this armature reaction.
હું પ્રિન્સિપલ ઓફિસમાં જઈ રહ્યા એ પછી હું ઊભી જતો હતો કોઈ પણ